Hello, welcome back to Chapter 9, Section 6, Solving Quadratic Equations by Factoring. In this example, like a lot of the examples that we're going to be doing, we're going to involve physics and problems that involve objects or what we call free-falling bodies. In this case, it's literally a body, it's a diver. All right? The height of the diver above the water during a dive can be modeled by this function. The height at time t, they left that out, they shouldn't have left that out, equals negative 16t squared plus 8t plus 48. Now let me break this down for you and tell you what this means. You don't need this for the problem, but you need it so that you understand that this is like, oh, when are we ever going to use this type of thing? The negative 16 is half of the acceleration due to gravity on Earth. Acceleration due to gravity on Earth is 32 feet per second. The half comes from calculus, and I'm going to leave that alone for just a moment, or actually for a while. The negative means that gravity is pulling you down. If up is positive, down is negative. Okay, got that. The 48 is the height when the time is 0. So the instant that the diver jumps off, or I don't know, I think she's going to smack her belly. I don't know. That's not going to be good. But the instant that the diver starts to go into the dive, he or she is 48 feet above the surface of the water. Okay? Now what does the 8 do? The 8 raises it up a little bit. So actually the path is going to go up and come back down. If the diver just stepped off and fell, which some people do that, then there's going to be nothing here, right? This actually is what we call the initial velocity or vertical velocity, which is the speed that she sends herself going upwards. Now, of course, she's also going to go out, but I'm not worried about the horizontal stuff. I'm only worried about going up and coming back down, okay? So that's what that is. This is physics. Now, the question is, what's the time that it takes for the diver to reach the water? So right here, you can kind of tell the way I have here, but right here, h equals 48 feet, but down here, the water is h equals 0. So this goes back to the idea that we want to find out where 0 is. So this tells me that h equals 0, so I'm going to put a 0 here. 0 equals negative 16t to the second power plus 8t plus 48. Now I got to factor that. The first thing I notice is that I have multiples of 8. I have a common factor of 8. So I'm going to divide both sides by 8. 0 divided by 8 is still 0. Negative 16 divided by 8 is negative 2, so I get negative 2t squared. 8 divided by 8 is 1. So that's just 1t. I'll put the 1 in there, show the hidden 1. And then 48 divided by 8 equals 6. Okay, so those numbers are a little bit nicer, a little bit smaller, but still I've got this negative 2 here, which gives me that diamond factoring that I'm going to need to do. So let me set this up. Here's my diamond. Negative 2 times 6 is negative 12, and I put my 1 right here. These two are going to add up to the 1t. So what multiplies to give negative 12 but adds to give 1? Well, that would be 4 and negative 3. That means that, and I'm going to make my box here, I've got negative 2t squared, 4t from here, 3t from, or negative 3, excuse me, t from here, and I put the 6 right here. So what's inside my box is the same as what I have here, except 4 plus negative 3t gives me my 1t. I'm going to factor sideways, and I could either leave the negative where it's at or factor out the negative. I'm going to factor out the negative, so I get negative 2t. That leaves the other t and negative 2. And what do these two have in common? They both have negative 3. Negative 3 times t is negative 3t. Negative 3 times negative 2 is positive 6. So my factored form, I'll say 0 equals negative 2t subtract 3 times t subtract 2. So negative 2t subtract 3 equals 0, or t subtract 2 equals 0. I'm going to add 3 to both sides. Hopefully I squeeze this in here. I get negative 2 equals 3. Divide by negative 2, and t equals negative 3 halves. And of course that's time in seconds. Over here I'm going to add 2 to both sides. I'm going to get t equals 2 seconds. Now, obviously, the diver is only going to hit the water once. So the question is why did I get 2 answers? Remember, you always get 2 solutions to the equation. But what happens when you get 2, but logically you know it's only going to go once? Well, here's the deal. Starting at time equals 0, time does not go backwards. There's a lot of stories out there that involve time going backwards, but so far there's been no examples of it that I know of. So time goes forward. That means that every solution you're going to have to an application problem involving time, the answer has to be the one that's positive. So this means this is the correct answer. You cannot have negative time. And if you're wondering, well, what does that actually mean? Well, here's the thing. From here on down, this is not a diving problem. This is just a math solving quadratics problem. So if I did solve it by graphing, I would end up, I don't know if I got space here or anything, but I would end up with a quadratic function like so, where this is my x-axis, and this right here would be x equals 2, or actually t, but that's okay. And then my y-axis would be something like this. So again, you would go up and come back down, and you'd hit the water at 2 seconds. But this right here is the negative 3 halves, or negative 1.5. This part of the graph doesn't exist. I'm sorry, it exists on the graph, but this part of the graph doesn't exist in the real problem. The diver starts here, goes up, and comes back down. So the diver is actually starting right there. Okay, so when you do these, just give me the positive. All right, we'll see you in the next video.